you're going to find out, well, you're going to find out what is happening to x. So what's happening to x first? It's being multiplied by 2 and then added with 5. Okay, first multiplied, then added. So I have to deal with the addition first. How do I deal with addition? Yeah, I subtract. In this case, 5, yes, from both sides, because I want to make sure that I undo what is happening to the variable. 5 minus 5, 0. 0 plus 2x, 2x. That's like two properties right there. 105 minus 5, 100. So now what do I deal with? Well, now this goes back to our previous lessons. It's a one-step equation. Good. Both sides get divided by 2. I get x equals 50. Some of you have been doing this well on your homework. You get your answer, and then you do something that is unheard of for students your age, or undone, or not as often done by students your age. You check them. You check them.
Wait, what?
I know. It's amazing. You check them, and then you know that's the answer. And the thing is, maybe on the homework, you're like, I don't want to waste time to do that. But it's prepping you up for the quiz and test, because do you have any kind of resource during the quiz or during the test that is outside of yourself? Like, can you ask anybody, like, hey, what'd you get on that one? I mean, you could, but then it makes my grading easy. Or you can memorize all these equations, which, good luck, that's not happening. But you can do what to help you know your answer is right or wrong? You can check it, yeah, by plugging it in. So real quick, what's 2 times 50? 100 plus 5? That is the answer. That has to be true. Or I should say it like this. Open or close, Jensen? Murphy, open or close? Open. This is open. You know why? Because it has a variable. Now, when I put 50 in for x, when I put 50 here, I could do it mentally or I can actually work it out. Then it's closed. And when I put 50 for x, is this true or false? Wow, we'll never forget that. I wonder how long it's going to be. I guess the retreat didn't help us forget that. But anyway, yeah, you could make it a true sentence if you plug it back in. Okay, another example here. K divided by 3 minus 0.5 or minus 5/10 equals 4 and 5/10. Okay, so Matt, open or closed? Open. True or false? Peter? Neither. Okay. Betsy, is it addition, subtraction, multiplication, or division equation?
It has division and subtraction.
So that's two things. What do I deal with first, Michael?
Subtraction.
Why?
Because it's not the one not right next to the variable.
Yeah, it's the second thing being done. So first is being divided by 3 and then subtracted with 0.5. So how do I do the subtraction of 0.5, Caroline?
You add 0.5 to 4.5.
And don't forget your rules with decimal points. Yep. Oh, sorry. Yeah. You got that right, though. All right, what's 4.5 plus 0.5? 5. Good. And this is a one-step equation, which hopefully you guys are good with. Emma Grace, what do you do next?
You multiply both sides by 3.
Both sides get multiplied by 3. I get K equals 15. True or false? Nice. Oh, I said nice. Wow, you guys were all very firm on the close. I was like, oh yeah, that's good. Wait, no, it's not. It's open because it has a variable. If I put in 15 up here, so 15 goes right here, is that true or false? That's what I'm asking for. True. What's 15 divided by 3? 5 minus 0.5. So, yes, true. How many of you go on that? Like you're like, okay, just undo what's happening. All right, I'm going to give you another problem. This problem I want you to work more on your own because I want to see how you're going to handle it. It is a little bit trickier because it's awkwardly written. So 11 minus b equals 32. And this is where you're going to have to put some thought into your problem. Now, remember, what's this lesson called? Solve equations with 2 operations. Mr. A, there's only 1.
Incorrect.
There's 2.
Okay, there's 2. If you can see the 2, it makes it a little bit easier to deal with, but that's up to you. Yes, ma'am?
When you have a negative variable, do you multiply by negative 1?
Or you could divide by -1. Either one's going to give you a positive variable.
Oh yeah, I was just supposed to divide necessarily because
I mean, technically you can, but it's kind of like the fractional problems. You can divide both sides by that fraction or multiply by the reciprocal.
Because that's what I'm going. It's the same.
Yeah, and I guess you could think of it like this. Whatever undoes what's happening. If you can multiply or divide and undo it, it's good. Yep, good thoughts. Good thoughts. Okay, Nick, what are the 2 operations?
Say subtraction and I say multiplication.
Okay, where's the multiplication? I don't see that at all.
Put the 1 in front of the b.
Okay, so you can put a 1 right here. Okay, that's true. Where's the subtraction?
11 minus b.
Okay, now here's where the tricky part was. What undoes subtraction? Normally. Addition. Do I add something to both sides here?
Add 1.
Add negative.
Okay, you can add -11. Or add -11. But you can make it simpler. Michael, question?
Definition of subtraction.
Okay.
11 plus negative b. And you should use it to swap b and 11. So it's minus 11 onto both sides. So it's negative b equals 21.
So negative b equals 21. What does positive b equal? Good. Hey, Michael, that was actually very spot on and like what you're thinking through on this problem. You don't have to do that on this problem, what he went through, but do you see how he did the definition of subtraction? Stay, change, opposite. So it's right here. And then he did use the commutative property, and then it makes it super clear what to do next. How many of you got -21 though? All right, how many of you did not do this process? Like you just left it kind of like that? Okay, so Betsy, what did you do on this problem? Go.
Well, I kind of scratched it out.
Okay.
But I can still see.
Oh, okay.
Okay, so I did 11. I added 11 on both sides. So, no,
Okay.
subtracted.
Okay, now let me ask you this question before you keep going. You're right, subtract it. Is she allowed to add 11 to both sides? I'm asking that question, and I need an answer. This or that? Is she allowed to add 11? So just 11. I'm just sticking with positive 11. Is she allowed to do that? I see both this and that. According to the addition property of equality, she is allowed to do that. Like you're allowed to do that. So I'm just going to do what you did, like what you said you did, which I think you changed it, right? All right, what's 11 plus 11? And then 32 plus 11. So are you allowed to do that? And the answer is absolutely yes. You're allowed to do it. It's allowed. It's a property. But
I accidentally said add instead of subtract.
that's okay. If you did that help you get b by itself? No. So that's why you wouldn't do that. So the question is, could you? Yes. Would you? Probably not. So what do you do to both sides now?
Okay, so I subtracted 11 from both sides.
Are you allowed to subtract something from both sides? Yeah, you're allowed to do that. And would you do that in this problem? Yes. Okay, go ahead.
So then I just got b equals -21 because I knew it was negative.
Okay, so technically you would get this, right? And then you'd say the opposite of b is, the opposite of b is 21, so b equals -21. So yeah, you could do that too. Just be careful, guys. This is what I did to the other class. I should have done it with you, I forgot. But I had them work the problem, and I told them, all right, I'm going to come and check the answer when you're done to see if it's valid or not. And all I did was this. I hardly even looked at your answer and just did this. Check it, check it, check it, check it, check it, check it, check it. What'd you get? Yeah, check it. I don't care what your answer was. All I care about is if you know that's the answer or not. So how do I know that's my answer? B equals -21. Like, that's got to be the answer.
Check it.
Yes. How do I check it? Yes, ma'am? Sarah?
What you do is you put -21 into the equation, so it's 11 minus -21
Yes.
equals 32.
Which 11 minus -21 is 11 plus 21, which is 32. Did anyone get like 43 or negative 43 at all? Nobody? That's probably like you added 11 to both sides, and then you just kept it like that. But that doesn't work. 43 doesn't fit into that equation. Okay. Oh, what nice problems we've gotten. That was kind of a tough one, but I think you guys can handle it. But what about if you have a problem that doesn't have integers, but fractions? Dun, dun, dun. Which for a lot of us are not our favorite types of problems. Are they workable? Of course they are. Are they a bit tougher? They can be. But are there strategies to help you out? Yes, of course. Okay, how many of you like fractions? Ooh. Okay, so in the last class I had 2 people raise their hand. They like fractions. I'm like, what's wrong with you? And then now here 3 people like fractions, kind of. What's wrong with you? No. It's okay to like fractions. What about decimals, though?
Oh, yeah.
Oh, decimals are awful. They're awful. Okay, you guys like them. That's fine. Whether you like fractions or decimals or not, you should be able to deal with them. But if you really, like you just don't like fractions and our next problem, decimals, you can get rid of those fractions or decimals. Like get rid of them. Just eliminate them. Just deal with integers because those are easier. Sorry?
I know how to do it.
Do it.
Do you just feel like w divided by 18 minus 1 divided by 9?
Oh, okay, close. Like just kind of, you. Something about the denominator. Michael?
So I change 1/9 to 2/18.
Oh, so you guys are getting the common denominator with the 18? Okay, you could do that, but you'll still have to deal with fractions. I'm talking about not dealing with fractions at all. Get rid of them. No more fraction bar. How many of you like that idea? Kind of like, well, that's kind of interesting. I hate fractions. I hate them. I dream about them and they scare me. I hate parts of a whole. Yeah, I can't look at a pie that has a slice taken out. It bothers me. And you're going to have a hard life. Why? Does that kind of describe you? Oh, can you just work it that way? Yes.
Can we just suck it up and deal with the friends?
Oh.
You mean deal with life? Yes, you may. You're allowed to do
Well,
that.
that's mean. Why?
Yeah, you could do it. You could deal with it. Okay, let me give you a strategy if you don't. But can you add 1/9 to both sides? You get 8/9 equals w over 18. Multiply both sides by 18.
Yeah.
And get your 16, I believe, right?
Yes, that's what I think.
16 is the answer. Okay, this strategy right here may not seem very useful on this problem. I would say doing the way we just described is fine, but there's another way to do it with getting rid of all your denominators, and it is helpful, especially when you have multiple denominators like 18, 9, and 3. It's going to make it easier to deal with those. Okay, here's what I'm going to do. I'm going to use the multiplicative property of equality. Almost there. And then orient your body toward me. There you go. Perfect. Okay. What I'm going to do is I'm going to multiply both sides by the LCD of 18, 9, and 9. What's the LCD of 18, 9, and 9? Least common denominator. That's factor. That's the least common factor. 18. All right. 18 is the smallest number that all of them fit into. That's what we mean by LCD. Okay, ready? I'm going to do this. And if you don't like it, that's okay. I'm okay with that. I'm just giving you a strategy. Okay, I'm going to multiply both sides by 18. Am I allowed to multiply both sides by 18? Yes, that's the multiplicative property of equality. Now, do you guys notice what property is going to have to be applied here? So I'm going to do 18 times W18, W over 18, 18 times negative 1/9. That seems like a lot, but it's actually not that bad. Watch what happens. What's 18 times W over 18? W. Isn't that nice? So what happens to these denominators? Cancel out. 18 times 1/9. Yeah, why?
Because you cross them out.
So it's 2 times 1? 2. Okay, fine. I had to do it to both sides, so here, anything happen? This equation is equivalent to the first equation. That means they're the same. How do I solve this equation? And look what I got. Same thing you did. Now, on this problem, either way is going to be fine. Either way. But how many of you understood which property I applied when I multiplied both sides by 18? Do you guys know what property I used? Sorry, when I multiplied both sides by 18. The multiplicative property of equality. And then what property did I use here? Distributive. And then I get this. Do you have to use that? No. It's just an option. I have maybe two answers. Go ahead.
Can you get common denominator for dividing the bigger one instead of just multiplying the smaller two?
Well, this one's nice because you have 18 and 9, but sometimes you have 18, 9, and 4. So then that won't work.
Yeah. Well, what if you just had two? Like, if it was like something like that, would it be okay to like divide it like that?
So you basically, if you multiplied. Okay, what would you do? I need to hear your thoughts. What would you do?
According to like if it's just like 1 like or 2 and 18 and like 1 and 9, could you divide like the 2 18 by 2 and get 1 9 also, and then 1 9 whatever 1 9 or whatever number?
I think that way I'm not super getting it because I'm having trouble understanding it, but that may work on this problem, but it probably won't work on all of them. So.
And the other thing is on this one.
Yeah, second, number 2.
If you get the
So I didn't have an answer for his first question, by the way.
if you
I'm
get a common
0 for 1.
denominator, then, like, however, like you get a common denominator for all of these, but, and then just do the numerators. Like forget about just do it all the same. Just
Like deal with W 1 and 7.
Yeah. But
That
first you gotta get the common number for all of it, so it'd be W 2 and 14.
Okay, gotcha. I see what you're saying. Get the common denominators 2 and 14. We'll change your numerators. Just deal with that. No, because it will deal. You can deal with the addition subtraction that way, but then you have to multiply, divide by reciprocals or.
But in this problem,
So it doesn't.
This problem would still
Because
work.
you get W equals 16 if you just do the top.
Okay, yeah. Again, on this problem, and consider yourself lucky. Actually, in the last class, the last problem I gave him, got the answer. I worked it out. People were like, Mr. A, I got the answer. I didn't do it that way. You consider yourself lucky, because that doesn't happen. But yeah, it could work, but it doesn't work on all of them. Okay, let me give you this next problem here. And you're going to do it on your own. I'm going to check you to see how you did. On page 53, where it says try these at the bottom, number 4, solve for Z. Check your solution. See if it actually is true or false when you put it in. So page 53, try these. Number 4. When you're done, just raise your hand. I'll come check it. If I say yay, you got it. You can say yay too. I say nay. Find out what happened, or ask a question. Number 4.
Should you simplify in like the middle of the problem?
I don't always do that, because sometimes what happens is you could have used that unsimplified form to add or subtract easier. So not necessarily, but that takes some. It just depends on the situation. Okay, if you get an answer, please raise your hand. I will come and check it. And yay or nay is my response. Nay. Yay.
I have a question. So, right here, is the last problem. That was that.
Okay, what's the LCD?
That of 24.
So multiply this by 24 and that by 24. So do you remember I put parentheses? Yeah, because that helps you to keep it straight. And then multiply this also by 24. Yep. Okay, so you're doing distributive property. You're doing this times that, this times that.
That would be Z.
Yep. Okay, sorry. I think I know what happened. Sorry, this one or this one? Oh, I'm sorry. That's it. I was looking at this. You're right. Yay. Is that the answer? Okay. Yay.
Yay.
I'll come around here now. Yay.
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 I have a question.
Yes.
So, do 2 plus, and I was trying to do it this way. It would be 2 plus a half.
No, it's 2. Did you cancel that one? Or that 12? So it's just 2 times 1, which is 2.
Okay.
So z plus 2.
For this part, it was 5/12, and I cross it out again. But then would you do 5 times 2?
2, yes. It's 10. And then solve it. Yay. Yay.
Yay!
So this is. So she get a positive sign here because you start out positive. Do you know why I changed the negative there? So just a plus sign. Yep. And then you do 5 times 2. So that gives you 10 right there. 5 times 2 is just 10. And then work it out. It should give you an answer. This one? Wait, where? The sign. It should be positive. All right, it's hard for me to focus when it's getting a little bit louder. I haven't come to everyone yet. Sorry. But, yes, yay. The answer, let me just give it since most of you are getting it. Z equals 8, positive 8. So now you can all say yay or nay. Now, I'm going to do this real quick if you guys are paying attention. I'm just going to do it like this. And some of you are trying this method out, which is great. Just be careful. Okay, you're going to do 24 times z over 24, which is what? Z. Because it cancels, the 24 is canceled. 24 times 1/12? Positive 2. Yeah, positive 2 because 24 and 12 cancel each other out. All right, 5/12 times 24. These two cancel each other out. Becomes 2 times 5, 10. So subtract 2 from both sides. Z equals 8. That's how I get my 8.
Look at the way you did and the way I did it. I did the normal way. And like,
The normal?
the
Okay.
only thing that's...
Wait, does this make me abnormal?
No.
Yes.
The only thing that's like different about that way is, so in that way you have to do minus 2 on both sides. In this way you do minus 1/12 on both sides.
So you get 4/12 and then multiply by
But they're
24.
basically doing the same.
Yeah, you're doing the same thing. You're in essence doing the same thing. Yep. Okay, good. How many of you have questions on this? Like you didn't get it or that doesn't make sense? It's okay if you don't understand it. Yes, ma'am?
So you're always going to either have multiplication with addition or subtraction. So you're never going to have like 2 multiplications or 2 divisions.
Well, you could technically, but that's this afternoon.
Oh, no.
Yeah. Not that. I'm not doing that. I'm not going to throw that out to you this morning. That doesn't make sense. It's too early. All right, let's do another problem here. This one's a little different, not because it has fractions or decimals, although it does have a decimal. And this is actually called example 1 for some reason, after our 4th time. 2p minus 7p minus 1 and 98 hundredths equals negative 35. Okay, so just a little bit more going on. And you notice my variable p is not in one spot. It's actually in 2 spots. So when I look at these kind of equations, my first step is to get both sides to be as simple as possible. So look at the left side and look at the right side. Can I simplify that right side anymore? No, but can I simplify the left side anymore? Okay, how? Add like terms right here. What's 2p minus 7p? Negative 5p minus 1 and 98 hundredths equals negative 35. So that's what my equation becomes. Still the same because I just combine like terms. All right, great. All right, what's happening to p? First it's being multiplied by negative 5 and then subtracted with 1.98. So what do I deal with first? Yes, ma'am? Add 1.98 to both sides. And when you do that, be super careful with your decimal place because that does affect your solution. So I get negative 5p equals. Now, I have a negative 35 plus 1.98. I'm adding two numbers with different signs, so what do I actually do? Subtract.
I got 34.02. Negative 34.02.
I got negative 33.
Yeah, watch what happens here because the carrying is going to affect. So I'm subtracting here. That's 4, borrow, 2, 0, 3, 3. So 33.02. But is that my answer?
No.
For that part, why not? Sorry, there's something even wrong with this right here.
Negative.
Yes, ma'am? It has to be negative. I'm going to rewrite it because it gets sloppy. Negative 33.02. Good. It has to be negative. Yeah, negative 33.02. Okay, now what do I do, Betsy?
Do you add 5 to both sides?
I could add 5 to both sides, but I'm left with 5 minus 5p, and then I added 5 to that. But what's going on with p and negative 5? So what undoes that? Divide both sides by negative 5. That's what I want to do to undo this part. And so I go 33.02 divided by 5. Now, do you notice in my division, I don't have any signs like positive, negative? What's a negative divided by a negative? So I already know that this is going to be positive. I don't even deal with the negative signs anymore. 5 goes into 33. 6 times the remainder of 3. 5 goes into 30. 6 times with no remainder. 5 goes into 2. 0 times. So I add another 0. 5 goes into 20. 4 times. P is equal to 6.604.
Could it be negative?
600.
Yeah, good question. Positive or negative?
Positive.
Wait, what about those negative signs?
A negative divided by negative is positive.
Yeah, negative divided by negative is positive. So good. Now, I am asking you to check these, but you don't have to check them because this is a little bit more complicated. You can do it by rounding, just by estimating a little bit. So here, what is 6.604 round to the nearest integer? 7. All right, ready? What's 2 times 7? So I'm just writing it up here. What's 7 times 7?
49.
Yeah, so I get negative 49. And then what's negative 1.98 round to? Okay, so this should be very close to what a true equation would be. So what's 14 minus 49? Negative 35 minus 2. Negative 30. Oh, man, that's not it, is it? Why?
Because we rounded, and rounding's not always.
Yeah, I'm not expecting this to be exact, but negative 37 equals negative 35. That's pretty close. I rounded this up, so that means that side naturally would be a little bit higher in this case, on this problem. Okay? How many of you are going on that? So good, I'll give you this next one, and all I can say is good luck. Okay. This is example number 2, our second example. 7y minus 1.8y plus 4.3 equals negative 8 plus 7.1.
You said minus 4.3.
Sorry. 7y minus 1.8 plus 4.3 equals negative 8 plus 7.1. So that's the problem. Yes, sir.
On our homework, do you, when we're checking it, do you not want us to round?
You can round, especially on decimals or fractions. But the more exact you put in your checking, the better you'll know if it's right or wrong. So I can't promise. All right, are both sides simplified?
No.
No, what's wrong with the left side? What's 7y minus 1.8y? 5.2y plus 4.3 equals, anything wrong with the right side? Add like terms. These are also like terms. They're constants. What's negative 8 plus 7.1? Negative 0.9. You subtracted and make sure you lined up decimal places. You got 0.9 and it has to be negative. All right, how do I solve this one, Wyatt?
You subtract 4.3.
Uh-oh. I have a negative minus a positive.
You're just adding
Oh, okay. That's comforting. Oh, yes. Negative 5.2 equals 5.2y. What does y equal?
5.2.
Sorry? Negative 1. Because 5.2 times negative 1 equals negative 5.2. Negative 1. So sometimes it'll be nice. Not too bad. Sorry. Let me check my time.
Is 9?
Give me a question. Yes, ma'am? So did you get negative 8 plus 7.1 is negative 0.9? Okay. And then you subtracted 4.3. So this problem right here, it's actually just adding the two negatives together. You get, it's a negative minus a positive. You're adding two negatives, yeah. Yeah, so you get negative 5.2. Yes, sir.
So I plugged it back in. Are we sure it works?
I hope so.
Right.
Okay, here's what we could do. What's 7 times y?
Well, I was doing my negative.
And then what's negative? So that becomes, it's actually doing something like this. And then that. So does that check?
I messed up at negative 100.
That's okay. All right, but yeah, if you check it, and if you do in your head, you may have some success. You may be able to keep numbers straight, but if you actually write some numbers down, that'll help you to make sure even your estimate's good. Okay, last problem for today. And you think I'm going to let you go with an easy one?
No, give us a hard one.
Oh, great suggestion. On page 53, try these number 9. Number 9. Yes. Your reward, you get to do that problem.
Yeah.
Yes, I know. I've been guilty of that many times. Oh, that's harsh.
Whoa.
Wait, what?
I better not find out who said that, because I'll give them a real punishment. All right, get to work, guys. Get me what t is going to be. It's 5 minus 8t minus 7 minus t equals 16. And you're like, I got an answer, but I hope it's right. I don't know. Plug it back in. Put it back in. See if it works. If it does work, great. If it doesn't work, you did something wrong. Notice that the left side is not simple. Can I make it simple? Yes. But you have to be super careful when you do that. Because signs. The definition of subtraction. What? Yay? Yes. Let me see here. How'd you combine these? Well, what did you combine, I guess?
Well, I did the 18 and I did minus.
Oh, sorry, I was looking at the wrong one. Okay, AT and then AT. Okay, that's the tricky part. It's negative AT.
Oh,
So that should be negative, and then negative, and then that's positive 5.
Okay.
Yeah, and that's tough, and I'll show you how I can tell if it's that or not. Yay. Yay. Now, this is the one where, Mister, I didn't do it that way, but I got it right. How disappointing. Yay. Yes, ma'am. So, which ones did you combine together? What do you get when you do negative 8t minus t? You get negative 9t. Because you did negative 8 plus negative 1. And then what's 5 minus 7? Negative 2. Okay, so I think all you have to do is work it out. Yay.
Yay!
Yay. Yay.
My phone goes to scare you,
Okay.
I need my stick.
Okay. Yay.
Okay.
All right, listen up. This is how you do these problems. If you got the right answer without doing this, you can breathe a sigh of relief, but it's not going to help you later on. This is what you do. You guys already noticed that you have like terms like I have a t here and a t there, right? And some of you did this. I think this is going to help you out. You apply the definition of subtraction. So this is what this is what either you're thinking or writing down. 5 plus negative 8t. Minus 7 plus negative t. How many of you did the definition of subtraction on those?
I did it, but I didn't do subtraction.
Okay. So, do you guys notice there is no subtraction going on here if you're dealing with algebra? You're actually only adding 5 plus negative 8t plus negative 7 plus negative 2. Negative t, excuse me. But anyway, what's negative 8t and negative t going to give me? Negative 9t. And you're like, well, how'd you get that? It's right here. What's negative 8t plus negative t? Negative 9t. And what's 5 plus negative 7? Negative 2 equals 16. This is what you should have in order to get these next ones correct. Then you add 2 to both sides. Negative 9t equals 18. So t equals negative 2.
I got negative 2 plus negative 19. It's the same thing, right?
Negative 2 plus negative 19. Yep. See, is there a commutative property for subtraction? No. But if I make subtraction into addition, these guys can move around. Goodbye.